Alright, quick, hands-on tour of software and web exploitation, focused on how attacks work and how to shut them down. First, privilege. On Unix, setuid lets a program run with the file owner's power. Sometimes that's root. Problem. A tool grabs elevated rights and accidentally uses them while handling user input or calling system. Defense. Least privilege. Drop to the real user ID before touching untrusted stuff, only elevate for the tiny moment you truly need it. Avoid system. Prefer exec, so data never gets parsed as code. Memory bugs next. Picture a stack frame, locals, saved frame pointer, then the return address, the crown jewel for attackers. Problem. Buffer overflow. Right past the buffer smash, the return address, hijack control flow. Defense. Stack canaries, ASLR, NXDEP. Attackers adapt. Return to libc jumps into existing code like system, using carefully stacked arguments. Defense. Keep ASLR strong, compile with PIE, enable RelRo, enable stack protectors. Sanitize and limit inputs, so the overflow never happens. Crash on anomalies, log and alert. Web time. SQL injection is what happens when code and data get mixed into one string. Problem and apostrophe breaks out. The query mutates, where user, and pass, becomes return everything. Defense prepared statements, with bound parameters. Full stop. XSS flips the script to the browser. Problem unescaped user input, renders as live JavaScript stealing cookies, hijacking sessions, or defacing pages. Defense, encode output by context. HTML attribute JS URL. Use a strong content security policy and never trust raw user HTML. CSRF rides your existing session to forge actions you didn't intend. Defense, synchronized anti-CSRF tokens. Same site cookies check origin.referer on sensitive endpoints. One more, TLS and PKI. Problem, cert validated as CA signed but hostname not verified. Easy MITM. Defense, enforce hostname verification in your TLS stack. Quick checklist, drop privilege early, rise late, and only briefly. Ban unsafe functions, prefer bounded copies, prefer exec. Turn on stack canaries, turn on ASLR, turn on NXDP, compile with PI, enable RelRo, use prepared statements everywhere, encode output and ship a tight CSP, add CSRF tokens and same-site cookies, verify TLS hostnames, always. Cybersecurity isn't about memorizing tricks, it's about isolating code from data and shrinking the attack surface. Build with that mindset, and you break entire classes of bugs before they start. See you in the lab.